Welcome to this video on job safety analysis. This process serves as a standardized operational methodology designed for hazard prevention and risk control in the workplace. A common misconception is that safety protocols slow down business, but the reality is that safety directly drives operational profitability. When you combine robust safety standards with team productivity and quality control, the result is higher overall profits. Systematic hazard reduction directly minimizes costly operational downtime caused by accidents or equipment failures. Standardized job methods guarantee consistent quality across all field operations. Ultimately, prioritizing worker protection isn't just an ethical responsibility. It directly correlates with sustained financial margins and long-term business resilience. At its core, a job safety analysis breaks any task down into separate steps, evaluates associated hazards, and determines the appropriate controls for each identified risk. To achieve our core objective of hazard prevention, we examine four key operational elements together: the worker, the task, the tools being used, and the broader workplace environment. By understanding how these four elements interact during an activity, we can isolate vulnerabilities early. This structural approach guarantees that no risk factor is overlooked before the job kicks off. Implementation follows a strict three-phase timeline. Phase 1 begins with a dedicated team meeting and direct field observation of the task. Never skip seeing the work in person. Phase 2 covers documentation and approval. The JSA form is systematically completed, signed by relevant personnel, and submitted for mandatory management review. Finally, Phase 3 centers on communication and display. Once approved, the JSA must be actively explained to every worker involved and visibly posted right at the specific worksite. Step 1 of the protocol requires formulating a clear job method statement. This requires establishing four critical components. First, define the exact physical boundaries of the work area. Second, detail all job preparations, including staging areas, required permits, and specialized tools. Third, break the execution down into chronological micro-actions so every move is planned. Fourth, outline post-activity tasks like site cleanup, handover, and securing the area. Clear method statements eliminate guesswork and lay the foundation for accurate hazard identification. Step 2 focuses on diagnosing potential hazards by asking two fundamental questions. What can go wrong, and how likely is it? We categorize risks into common hazard profiles. Atmospheric and chemical hazards include toxic gases, oxygen deficiency, or fumes. Kinetic and physical hazards cover slip and trip risks or working at heights. Mechanical hazards involve pinch points, moving machine parts, or getting caught between objects. Identifying these profiles systematically ensures every potential threat is caught before execution. To prioritize our response effectively, we calculate a quantitative risk rating. We use a simple operational formula: consequence plus frequency. Asterisk probability equals risk rating. Consequence measures the severity of potential injury or operational damage. Frequency tracks how often the worker is exposed to the hazard. Probability is the mathematical likelihood of the hazard actually occurring. Quantifying risk removes subjective opinion and provides an objective score to guide our required escalation and approval channels. Our risk response matrix establishes strict operational action thresholds. A score between 0 and 20 means a formal JSA is not mandatory, and standard safety protocols apply. A score between 21 and 44 requires standard mandatory review and mitigation, signed off by the department manager. However, a score between 45 and 100 triggers a mandatory escalation. Work must halt immediately until the subsociety chairman reviews the risk and grants formal executive sign-off. Thresholds keep everyone accountable. Step 3 filters identified hazards through the hierarchy of controls, listed from most effective to least. We start by trying to eliminate the hazard completely. Next, we look to substitute it with a safer alternative. If that isn't possible, we isolate people from the threat or implement engineering controls to modify equipment. Administrative controls follow, altering procedures and training. Finally, personal protective equipment, PPE, serves as our last line of defense, never our first resort. Here is the complete hazard management workflow in action. It starts in the field by identifying the task. Step 1 isolates actions via the job method statement. Step 2 uses diagnostic questions to surface hazards, feeding those values into our risk formula. The resulting risk score hits the response matrix gateway. High scores trigger approver assignment, while control filters, from elimination down to PPE, are applied. The final output is an approved JSA communicated and posted at the site. To wrap up, remember these non-negotiable directives. First, never skip direct field observation during team meetings. Second, apply the hierarchy of controls sequentially. Never default immediately to PPE without attempting elimination or engineering fixes first. Third, strictly follow the risk matrix for required manager approvals. Most importantly, an approved JSA is useless sitting in a binder. It must be actively communicated to all working personnel and visibly displayed at the job site. Thank you.